Could a single volcanic eruption have killed 99% of humanity? The Toba supereruption may have reduced our species to just a tiny group of survivors, no more than a few thousand people. But was it luck, location, or sheer resilience that saved humanity? The answer might just surprise you. The supervolcano that redefined catastrophe. Imagine a moment in Earth's history when the very ground erupted with such force that it forever changed the planet's surface. This was Toba, located in what is now Indonesia. The Toba supervolcano unleashed an eruption so massive that it left behind a crater nearly 100 kilometers wide, a space that could fit an entire small country. But the crater was just the beginning. The true destruction of Toba came from its unimaginable power, a scale of eruption that few places on Earth have ever experienced. To understand why Toba was so catastrophic, we need to first understand supervolcanoes themselves. Unlike regular volcanoes, which occasionally spew out lava and ash during eruptions, supervolcanoes build up a colossal reservoir of magma over thousands, sometimes millions of years. The problem is, this magma doesn't get released in small, manageable amounts. Instead, pressure builds until it reaches an explosive point, releasing pent-up energy in one catastrophic outburst. A supervolcano's eruption isn't just some volcanic event. It's an earth-shaking disaster that can span continents, even altering the global environment. And Toba, it's one of the largest supervolcanic eruptions we know of in Earth's entire history. When Toba erupted roughly 74,000 years ago, it wasn't subtle. The numbers are hard to grasp. 2,800 cubic kilometers of magma erupted from the ground. That's enough to fill more than 1,100 Olympic-sized stadiums full of molten rock. To compare, the infamous eruption of Krakatoa in 1883, which was considered one of the deadliest volcanic catastrophes of modern times, released about 20 cubic kilometers of magma. Toba dwarfs that figure. It unleashed an ash cloud that soared so high it reached the stratosphere and spread across the globe like a dusty shadow. This ash didn't just linger in one area either. It fell across an estimated 38 million square kilometers, an area nearly as large as Asia and much larger than the entire continent of Africa. Archaeological evidence shows that ash rained down as far away as southern India, over 7,000 kilometers from the eruption's epicenter. In some places closer to Toba, this ashfall formed layers so thick they measured over 6 meters deep, enough to bury buildings, farmland, or entire habitats. Pyroclastic flows, those fast-moving avalanches of hot gas and rock, covered the surrounding landscapes, entombing them under layers of debris up to 600 feet thick. That's taller than the Statue of Liberty. But there's more to Toba's legacy than just ash and magma. Scientists use something called the Volcanic Explosivity Index, or VEI, to measure the magnitude of volcanic eruptions. This scale assigns numbers from 0 to 8, with 8 being reserved for eruptions of truly apocalyptic proportions. Toba hit the top of the scale with a VEI 8 score, marking it as mega-colossal. To earn this ranking, an eruption must eject at least 1,000 cubic kilometers of material, and Toba more than doubled that minimum. Reaching VI 8 is so rare that it's thought to happen only once every 50,000 to 100,000 years, and as far as we know, Toba is one of the very few eruptions to ever achieve this rank. The true consequences of Toba's size weren't felt just locally. A plume of sulfur dioxide blasted into the atmosphere alongside the ash cloud. As the gas mixed with water, it formed tiny sulfate particles, which then reflected sunlight back into space. This didn't only darken the skies, it began a chain reaction with consequences for the entire planet. Temperatures didn't just drop a little, they plummeted. Scientifically, this is known as a volcanic winter, where sunlight is blocked by volcanic debris for extended periods, cooling the Earth's surface. Estimates suggest that for at least 6 years following the eruption, global temperatures could have declined as much as 5 to 6 degrees Celsius. Don't let those numbers fool you into thinking the difference was minor. Just a few degrees of cooling can disrupt ecosystems, halt agriculture, and reshape entire climates. At its peak, Earth may have experienced its coldest temperatures in over 100,000 years. Lush forests and grasslands dried out and withered under this prolonged cooling, while animals, lacking food or drinkable water, began to die off in enormous numbers. This wasn't just about the local environment. It affected climates worldwide. Glaciers may have advanced. Rainfall patterns likely shifted dramatically, creating droughts in tropical regions while flooding others. In short, Toba's eruption didn't just scar the land around it, it sent shockwaves through nature itself, creating conditions that life had to fight to survive. What makes this eruption even more remarkable is the timing. Toba didn't just happen during an ice age when climates were already cooler than today. It struck at a unique moment in human history. Early Homo sapiens had begun spreading out across Africa and potentially beyond, developing tools, shelters, and other innovations that helped them navigate the harsh world of the late Pleistocene. But no invention prepared them for the devastation that Toba unleashed. This wasn't just an eruption, it was a turning point for life on Earth. Toba's scale redefined how violent and far-reaching a volcanic event could be. It didn't just shape landscapes, it reshaped climate systems and entire ecosystems. And this wasn't merely a geological story, it was also a biological one. While Toba itself was devastating, what came afterward was the true test of survival, altering not just ecosystems, but the trajectory of human existence. But what made Toba so uniquely deadly? The true danger wasn't just in the eruption itself, it was in how far its reach extended and how long its effects lingered. A world plunged into darkness. What happens when the sun itself seems to disappear? That's what the Earth may have felt like in the aftermath of Toba. The eruption didn't just fill the sky with ash. It unleashed a volcanic winter, a phenomenon caused by the massive amounts of sulfur dioxide thrown into the atmosphere. This gas rose into the stratosphere and reacted with water vapor to form tiny droplets of sulfuric acid. These droplets, though microscopic, acted like mirrors, bouncing sunlight away from the planet and dropping global temperatures. This effect wasn't just slight, it was dramatic. Estimates suggest the aftermath may have seen global temperatures fall by 5 to 6 degrees Celsius. To put this in perspective, even a drop of 1 or 2 degrees can have significant impacts on the environment. A larger cooling like this rippled across ecosystems, reshaping the planet in ways difficult to imagine today. While the Earth's surface froze under this temperature drop, the weather systems it depended on also unraveled. Rainfall patterns became erratic, and droughts likely strengthened in regions heavily reliant on monsoon rains. What made this disruption even worse was the longevity. Ice core samples indicate that this cooling effect wasn't fleeting, it lingered. Sulfur levels from the eruption can still be traced in Greenland's ancient ice layers, where researchers find evidence of increased dust deposits and colder conditions lasting for several years or perhaps longer after the eruption. Plant life struggled to survive these abrupt changes. With less sunlight reaching the Earth's surface, photosynthesis slowed, and in many cases, it stopped altogether. Crops wilted, forests thinned, and entire ecosystems began to collapse. Ashfall from the eruption added to the damage, covering vast stretches of land and creating an effect called mock aridity. This happens when ash blankets the soil so deeply that even rainwater has difficulty seeping through. Even the hardiest plants suffocated beneath layers of ash, while surface water became contaminated by toxic chemicals, leaving fewer resources for both animals and humans. Toba's eruption effectively choked the landscapes it touched, leaving forests stripped bare and rivers poisoned. Animals dependent on this vegetation as a food source didn't stand a chance. Herbivores began dying off and carnivores soon followed. Whole food chains teetered on collapse as species struggled to adapt to the expanding scarcity. This isn't mere speculation. Scientists can see similar patterns in the fossil record following major volcanic events in Earth's history. Large mammals, in particular, likely faced immense hardship as the Toba eruption and its aftermath wiped out vast areas of habitat. Meanwhile, weather didn't just cool, it changed. The unpredictability of this post-eruption climate made things even harder for life on Earth. Volcanic activity on this scale can weaken systems like the Asian monsoon, which is responsible for much-needed rain across critical agricultural regions. In the case of Toba, it's thought that the disruption to rainfall patterns may have led to prolonged drought conditions in areas like the Indian subcontinent. Other areas in the tropics likely experienced similar issues, with wetlands drying up and savannas disappearing under the stress of these global disruptions. But perhaps the most compelling evidence comes from ice cores taken from Greenland. Locked within these frozen time capsules are sulfur deposits precisely matching the signature of Toba's eruption. These same ice cores show increased levels of dust and corresponding signs of climate cooling. Researchers estimate that Toba ranks as one of the largest sulfur loadings ever recorded in these cores, highlighting the eruption's massive atmospheric impact. The results weren't just isolated ripples, they were waves hitting every corner of the globe. And yet, beyond these numbers and geological markers lies one undeniable fact. This was the ultimate challenge for survival. For humans alive at the time, the volcanic winter created a chain reaction of crises. As food sources dwindled and the climate became hostile, small hunter-gatherer groups saw their way of life grow unsustainable. Access to uncontaminated water became a challenge. Hunting became unreliable as animal populations shrank, and shelter was no match for the icy conditions sweeping across the planet. Even without modern technology, early humans were resourceful and adaptive, but surviving Toba required something more. It pushed humanity's resilience to its absolute limits. While the story of Toba often focuses on the eruption itself, its true power lay in what it set into motion. This wasn't just an event that reshaped the ground where it occurred. It tested ecosystems, altered climates, and left a stark message written into Earth's history. Life, as fragile and persistent as it is, faced one of its greatest threats. For our species specifically, this catastrophe wasn't just another challenge to overcome, it forced us to adapt or disappear. This planet-wide reset gave new urgency to how humans interacted with their world. Our survival hinged on an ability to find pockets of stability, to innovate when resources ran short, and to endure not just short-term hardships, but years of brutal survival amid an altered world. The Toba eruption, with its volcanic winter, left no corner of Earth completely unaffected. Every species, every climate system, every stretch of land bore some impact. But while the environmental consequences tell a clear story of destruction, they also set the stage for a defining moment in human survival. The Toba eruption wasn't just a geological event, it tested how far life itself could stretch before breaking. But the real question is, how exactly did humanity endure the challenges that followed? The genetic bottleneck, humanity's close call. Could humanity have truly come within a hair's breadth of extinction? That's the question at the heart of the Toba catastrophe theory, a concept that proposes the eruption of the Toba supervolcano didn't just reshape Earth's environment, it also nearly wiped out Homo sapiens. At its core, the theory suggests that the devastating consequences of Toba's eruption reduced the human species to a population as small as a few thousand individuals. If true, that means everyone alive today might trace their lineage back to this small, fragile group of survivors. The evidence for this idea isn't just buried in the ash of Toba, it's written into our very DNA. Genetic studies have uncovered a mysterious bottleneck in human genetic diversity around 74,000 years ago, corresponding remarkably well with the timing of the eruption. To understand what this means, think of humanity's genetic diversity as a massive library filled with countless unique books, each representing a different version of our DNA. A bottleneck event is like a catastrophic fire sweeping through the library, destroying most of the books and leaving only a handful intact. Every book created afterward would be a copy of those few survivors, drastically limiting the variety. This concept has real-world parallels. Take cheetahs, for example. Modern cheetahs are so genetically similar to one another that scientists have noted they could accept skin grafts from unrelated individuals without rejection, a consequence of their own population bottleneck tens of thousands of years ago. Similarly, humans exhibit surprisingly low genetic diversity for a species of our size and global reach, especially compared to species like chimpanzees. This lack of diversity suggests that somewhere along the line, our population took a serious hit, and geneticists believe that Toba might be the culprit. One of the strongest pieces of evidence linking Toba to this genetic bottleneck comes from studies of mitochondrial DNA, a type of genetic material passed down from mothers to their offspring. By analyzing family trees encoded in this DNA, researchers have found signs of a sharp decline in effective population size, the number of individuals contributing to the next generation. Some estimates suggest that this number may have dropped to as few as 1,000 to 10,000 individuals. If accurate, this means that most of the complexity and variation in early human traits were lost in one dramatic moment, leaving just enough people to rebuild the global population over millennia. But surviving this bottleneck would have been anything but straightforward. Picture a world where environmental conditions were already harsh, with the Ice Age bringing cooler temperatures and unpredictable climates. Now throw in the aftermath of the Toba eruption, a volcanic winter that darkened skies, disrupted ecosystems, and made food nearly impossible to find. Those who made it through would have had to be incredibly resourceful. It's likely that many small groups of early humans simply didn't, succumbing to starvation, exposure, or disease. The survivors were probably those who found themselves in very specific pockets of the world, where conditions were just manageable enough to eke out an existence. It's here that the story of survival becomes even more intriguing, because studies suggest that some of humanity's adaptations to extreme environments may have started with this event. Evidence indicates that the genetic traits helping our ancestors manage cold or arid conditions could have been strengthened during this time. In genetic terms, this means the eruption of Toba didn't just bottleneck our population, it may have actively shaped it. Researchers refer to periods like this as selective sweeps, when specific traits quickly spread to everyone in a population, because only those with the traits survived. Interestingly, this ties into something known as the Arabian standstill. According to genetic and archaeological research, early human populations outside of Africa may have paused their migrations during the period following Toba. This makes sense. Why venture into new, potentially even harsher environments while the global climate is in disarray? Genetic evidence from populations in regions like Arabia suggests they endured long periods of limited movement and harsh climate, further supporting the idea that Toba played a significant role in shaping migration and survival patterns. Of course, living with such a tiny population also comes with risks. When genetic diversity shrinks, it leaves populations more vulnerable to diseases or further environmental disasters. Any major blow could have been enough to finish off humanity completely, but somehow, against all odds, the survivors endured. Whether it was due to luck, adaptability, or the unique resources of their specific regions, these groups found a way to persist. And if this theory holds true, then the implications are staggering. We are all descendants of those who made it through, carrying with us the genetic legacy of their resilience. Every language spoken, every culture created, and every human innovation can be traced back to the same small cluster of ancestors who looked extinction in the face and kept going. But what if the Toba eruption wasn't solely responsible for this genetic bottleneck? Some scientists argue that other factors, like a sustained period of cooling during the Ice Age or separate migration bottlenecks, may have contributed. Artifacts and evidence from archaeological sites show that some human groups may have continued to thrive even during Toba's aftermath, possibly in isolated regions closer to the equator or near resource-rich coastlines. This raises questions about whether the eruption alone was enough to drive humanity so close to extinction, or if it merely added another layer of hardship to an already challenging existence. What's certain is that the genetic bottleneck is real, an undeniable marker of a dramatic decline in population somewhere in our past. Whether Toba was the sole cause or just one piece of the puzzle, the fact remains: humanity came dangerously close to disappearing forever. Yet, thanks to a small, resilient group of survivors, everything we now know, from civilizations to technologies, became possible. And it all comes back to a time when the odds couldn't have been higher or the stakes greater. The evidence that challenges everything. What if the Toba catastrophe theory is only half the story? While this theory has long suggested that the eruption brought humanity to its knees, newer evidence paints a picture that's far more complex. Not all human populations may have suffered equally, and some places appear to show little disruption at all. The idea that Toba's eruption completely reset human history is now being challenged by clues left behind in the earth, artifacts, and even our own genetics. In southern India, for example, archaeologists investigating the Jureru Valley made a striking discovery. Here, beneath a thick layer of ash deposited by the Toba eruption, they found Middle Paleolithic stone tools. But here's the twist. tools that looked nearly identical were also found above the ash layer. This means that humans, or at least their technologies, not only existed before the eruption, but continued to thrive afterward. The tools appear to show a surprising continuity of life and culture rather than a catastrophic reset. Radiocarbon dating even suggests that some of these tools reappeared in the region as early as 55,000 years ago, possibly pointing to a reoccupation of the area. This challenges the idea of widespread human collapse and suggests that some groups may have found ways to endure, or at least return. But survival may not have looked the same everywhere. Just 1,700 kilometers away in India's Middle Sun Valley, researchers found evidence suggesting a very different fate. This region shows signs of a major population decline after Toba, a stark contrast to the continuity seen in the Jureru Valley. What accounts for this discrepancy? One intriguing theory ties survival to geography. The Jureru Valley, for instance, was rich in natural springs, which may have continued to provide essential water resources even as the climate shifted and nearby regions dried out. It's a reminder that when facing catastrophic change, location sometimes makes all the difference. Further south, along the coast of South Africa, another set of clues suggests that early humans might have weathered the volcanic winter largely unscathed. Archaeological sites there contain layers of volcanic glass, the unmistakable fingerprint of the Toba eruption, sandwiched between human artifacts. Interestingly, the tools and artifacts found above the volcanic glass are nearly identical to those below, indicating no major disruption in activity. How could this be possible, given the global effects of the eruption? Researchers believe the answer may lie in the region's rich coastal resources. Warm oceans and reliable food sources like shellfish and other marine life could have created a critical refuge where humans found some measure of stability during the volcanic winter. These findings show that living near resource-rich coastlines may have been a key factor in survival during Toba's aftermath. Adding fuel to this debate, sediment samples from Africa's Lake Malawi offer a completely different perspective. Scientists studied microscopic charcoal and plant particles in lakebed sediments, expecting to find clear signs of reduced vegetation after the eruption. Instead, they found almost no difference in plant life before and after Toba. This lack of significant change contradicts the idea of a decade-long volcanic winter, devastating ecosystems across the entire globe. It raises questions about just how widespread or uniform the eruption's impacts really were. And then there's the role of genetics, a cornerstone of the Toba catastrophe theory. If widespread death and near extinction don't seem to match archaeological evidence in some areas, what then explains the genetic bottleneck found in our DNA? One explanation could be the founder effect. This concept suggests that the bottleneck may not have been caused solely by Toba, but by small groups of humans migrating out of Africa during roughly the same period. As these groups moved into new territories, their small size naturally limited the genetic diversity they carried. This pattern, especially pronounced in non-African populations, might help explain the reduced genetic variation without needing to pin it entirely on Toba. Additionally, genetic research into early human adaptations hints at another fascinating possibility. Around 72,000 to 97,000 years ago, studies identified several selective sweeps, periods when advantageous traits quickly became common across populations. Some of these traits are linked to surviving extreme cold, conditions that may have emerged during both the Ice Age and Toba's volcanic winter. Researchers call this period of adaptation the Arabian Standstill, suggesting that small groups of humans in regions like Arabia adjusted to harsh, cold environments during this time. Toba likely compounded these difficulties, but it may not have been the sole driving force behind these adaptations. Ultimately, the evidence creates more questions than answers. For one, did Toba's impact vary so widely that some populations barely noticed it, while others were driven nearly to extinction? And how reliable are the methods we use to date and interpret this evidence? For example, the continuity of tools in Jureru Valley or South Africa hinges on accurate dating of the ash layers. Advances in technology might confirm or entirely reinterpret what we think we know. Similarly, the varying effects of Toba on environments around the world remind us that no disaster ever unfolds in exactly the same way in every location. What is clear, however, is that humans proved remarkably resilient in the face of such incredible challenges. Whether they lived in tropical valleys, along ocean shores, or near life-giving springs, certain populations found ways to adapt, innovate, or simply endure. While the Toba eruption undoubtedly ranks as one of the greatest natural disasters in Earth's history, it didn't spell the end for humanity. Instead, it highlighted how geography, resources, and sheer determination can tip the balance between life and extinction. So if Toba wasn't the single turning point for human survival, it still left an invaluable mark on our story, one of resilience and adaptation in the face of overwhelming odds. Resilience in the face of apocalypse. How did our ancestors turn one of the greatest disasters on Earth into a story of survival? To answer that, you have to imagine the challenges that early humans faced. The Toba eruption wasn't just a temporary disaster, it brought extreme cold, shrinking habitats, and food scarcity to an already unforgiving world. Yet our species managed to endure, adapting in ways that would define human history. At the heart of this survival story lies adaptability. Early humans were remarkably resourceful, crafting tools and finding ways to modify their environments to meet their needs. Archaeological evidence from South Africa provides a vivid glimpse of this resilience. Here, layers of volcanic glass from the Toba eruption are sandwiched between human artifacts, showing no interruptions in activity. People living along the South African coast likely relied on the region's rich marine resources, like shellfish and other seafood, for sustenance through the volcanic winter. This wasn't just chance, it was innovation. Accessing marine food sources wasn't only about proximity, but also understanding tidal patterns, safe harvesting techniques, and ensuring food supplies lasted through harsh conditions. Survival was deeply tied to geography. Not all populations experienced the same fallout from Toba's eruption. In areas like Africa and India, the cooling effect appears to have been less severe than in other parts of the world. This regional variation provided an important lifeline to some human groups. Compared to parts of Europe and Asia, where glaciers expanded and vegetation receded, Africa and India retained ecosystems that could still produce food and shelter. In regions like the Indian subcontinent's Jureru Valley, a remarkable continuity of life after the eruption can be found in stone tools, which are nearly identical before and after the layers of Toba ash. Such discoveries suggest that even in the face of disaster, some human groups managed to rebound quickly. But this doesn't mean survival was easy. The eruption left behind problems that extended beyond environmental disruption. The volcanic ash contaminated water sources, choking rivers and lakes that were critical to survival. Communities had to find unaffected springs or develop strategies to collect clean water. In regions where heavy ash blanketed the soil, plant life either adapted or disappeared. Animals that relied on these plants struggled, and humans who depended on the animals faced cascading food shortages. Still, our ancestors found ways to navigate these challenges, whether by following herds to less impacted regions or learning to supplement their diets with previously overlooked resources. Migration also became a crucial survival strategy. Small groups of humans likely began moving in search of more stable environments as local ecosystems broke down. This may have been part of what scientists call the Arabian Standstill, a period following Toba when migration patterns seemed to slow in areas like the Arabian Peninsula. Some suggest that groups paused to adapt to harsh conditions before pressing forward, while others may have completely rethought how and where they lived. Early humans were constantly learning, reshaping their methods of foraging, hunting, and shelter building to suit the altered world. The ingenuity of our ancestors wasn't just about tools and movement. Evidence from archaeological sites reveals that shelters became more advanced during this time. In colder regions, humans likely built sturdier living spaces, using natural materials like animal hides and insulating even the smallest gaps to keep out the freezing winds. Fire wasn't just a luxury, it was a necessity. Early humans developed better techniques for creating and maintaining flames, not only for warmth, but also for protection against predators in unfamiliar areas where they ventured to find food or resources. Resilience wasn't just about surviving the immediate crisis. What makes humanity's response to Toba so significant is how it set the stage for long-term innovation. Tools from this period show increasing complexity, with sharper edges and more intricate designs. One particularly advanced tool type, known as the microlith, may have been developed as a response to environmental pressures. Small, efficient tools that required less material to make, but could serve multiple purposes like cutting, scraping, or hunting. These tools didn't just improve survival chances, they became the building blocks of technologies that would propel human development for thousands of years. Still, survival often came down to finding specific pockets of stability. Coastal regions, as seen in South Africa, offered one form of refuge. Elsewhere, natural springs may have allowed communities to remain near vital water sources. Researchers believe such areas created havens where small populations could ride out the volcanic winter before beginning to recover. These scattered groups, each equipped with unique local strategies, were the seeds from which humanity's global spread eventually flourished. The success of these survival strategies also highlights why humans were able to adapt to future challenges. The Toba eruption was not an isolated catastrophe. It happened against the backdrop of the Ice Age, when the Earth was already a volatile and inhospitable place. Surviving Toba pushed humans to refine skills that would later help them conquer deserts, cross frozen terrain, and eventually build the foundations of civilizations. The ability to innovate, to take lessons from disaster and turn them into solutions, became a defining characteristic of our species. Toba wasn't the end of early humans, it was something far more important, an evolutionary turning point. Faced with collapsing food chains, harsher climates, and an uncertain future, our ancestors didn't just endure, they thrived in the cracks and shadows left by the eruption's destruction. Scarcity led to migration. Migration led to new tools, and new tools made future challenges more manageable. The networks of survival strategies that grew out of this era created the first steps toward global human expansion. All of that was born from a time when the sky turned dark, the earth grew cold, and life had to fight for every small moment of survival. But this fight wasn't just about holding on. The fallout challenged humans to grow stronger, more adaptable, and more inventive. And that's exactly what they did. The Toba supereruption wasn't just a natural disaster, it was a turning point that tested the limits of early humans. Once framed as a near catastrophe that almost wiped us out, it's clearer now that resilience and ingenuity define the human response. From harnessing coastal resources to advancing tools, our ancestors adapted as the world changed around them. This event reminds us of humanity's remarkable ability to face challenges and innovate under pressure. But what other moments like this remain hidden in our history, waiting to be uncovered? The story of Toba may run deeper than we imagine, shaping us still today.